Muy buenas tardes con todos. Es un placer para mí darles a todos ustedes la bienvenida, a quienes están presentes en este auditorio y a quienes nos ven en redes sociales. A nombre de la Universidad Técnica Particular de Loja, la carrera de Economía, la Cátedra UNESCO, les doy la bienvenida a este conversatorio denominado Modeling Social Acceptability of Sustainable Intensification. El expositor, el profesor Thomas Noke, es profesor de Forest Inventory and Sustainability Use y director del Instituto de Manejo Forestal en la Universidad Técnica de Múnich. El doctor Noke ha trabajado con varios proyectos y varias instituciones, entre ellas the Institute for Commercial Forestry Research en Sudáfrica, también el Instituto Forestal de Chile, pertenece al grupo de investigación IFOR 60 y también a la Chinese Academy of Investigation. Tiene en su haber más de 200 publicaciones, ha sido citado más de 5.600 veces y también ha trabajado con varios de nosotros en algunas de nuestras investigaciones. Antes de dar la bienvenida al ponente, les pido por favor a los presentes apagar sus teléfonos celulares. A la final pueden hacer sus preguntas y a quienes nos siguen por redes también pueden poner sus preguntas en redes y las haremos al final. Professor, it is a pleasure for me and also for the university to have you here, and always a pleasure to attend your presentation. Please welcome to the Professor Thomas Noke. Professor, the stage is all yours.
Good afternoon. And buenas tardes, ladies and gentlemen, dear colleagues and friends, dear students. It is a big pleasure for me to stand here and give a presentation about the social acceptability of sustainable intensification. Let me first thank the organizers, Santiago Ochoa, Liz Valle, Luz Maria Castro, Baltasar Calvas, and also Leonardo Izquierdo for the opportunity to give this presentation. So my topic, this modeling topic, is about land use. Land use is important. We still have significant problems. Consider that Ecuador alone has lost over the last 20 years 1 million hectares of the natural forests. And in this context, there is great hope into agricultural practices which can achieve a higher amount of food production per hectare to spare some land and without compromising other ecosystems. And this is called sustainable intensification. So the hope is that sustainable intensification can help to reconcile tropical forest conservation with high enough food production. My name is Thomas Knoke. I work at the Technical University of Munich. And why do I give this presentation here? That is mainly because I have a long-lasting relationship to scientists here in Ecuador who have become friends already and share part of their research with me. Let me mention, for example, Luz Maria Castro, and I listed here only the publications which we shared during the PhD thesis of Luz Maria. And then, of course, Baltasar Calvas, who is doing ongoing research on his PhD thesis, Santiago Ochoa, who has also finalized with nice publications his PhD thesis already. We have then Liz Valle. She is doing ongoing research on her PhD thesis, and new candidates, Jonathan Torres, for example, who is very new in our team, working here at UTPL, and the counterpart is Carla Pintado. She is also Ecuadorian from Cuenca. So this is a strong team, and based on the very nice research, strong research of this team, we have developed a model to investigate maybe some possibly undesired effects of policy interventions and also to investigate some consequences which are not so obvious of, for example, sustainable intensification. So the model here is now set up and enhanced to anticipate consequences and especially the social acceptability of this sustainable intensification. So it is based on a basic version which has already been previously published, and this is, sorry for the wordiness, it is based on satisfaction indicators of farmers. So we take the position of a farmer and look at the problem through the lens of a farmer. So the indicators which are used to model the satisfaction of the farmers can be subdivided in economic performance indicators, in labor demand, because labor is always scarce on the farms, and then 4 indicators which has been asked from the farmers. So there have been conducted interviews and the land use preferences of the farmers have been recorded. The indicators, they are specific for different land use types. So we consider 7 land use types, and for a landscape, the indicator level depends on the allocation of land. So how much land is allocated to which land use type. We also consider there's uncertainty. So simultaneously, we integrate multiple futures in our optimization. And then at the end, the idea is not to maximize a single indicator, it is to minimize the dissatisfaction. That is very academic, but it means the farmers have an idea about what is the best they can achieve, and they have an idea what they can actually achieve. And this distance between the best they could achieve and what they actually can achieve is minimized by altering the allocation of land to the different land use options. So, but this study I present here is based on a new publication with strong contributions of my colleagues, Liz Valle, Santiago, Luz Maria, and Balthasar. And this is enhanced by some aspects to consider the social acceptability of sustainable intensification in particular. So first, which region do we refer to? So we consider a landscape composition as a starting point, which we obtained from a nice study of a colleague, that is Julia Curatola. She's also has been part of the German research. We are continuing here in Ecuador. And the region we consider covers part of several provinces of Loja, Imbama, Sabanilla, Zamora. And this is the landscape section which we will consider. And all the indicators, information of the households, and the growth of the trees, the productivity of the agricultural pastures has been recorded here in this area. So that is the location I refer to. Now, I mean the initial landscape composition, which we obtained from this remote sensing study of Julia, is 50% still natural forest, 30% about is pasture, and 20% around is already abandoned area. We consider that the farmers have 7 options to decide how the land is used. So either they just can leave areas abandoned or can use this area to carry out afforestation with a native species, Andean alder, or they could use an exotic, that is pine. Another alternative is recultivation of the abandoned lands back to a productive agricultural use. And one option is intensive pasture recultivation, which is very important for us because by expanding this land use type, we can simulate sustainable intensification. The other alternative is the common land use, low input pasture, or they could clear new areas, they could remove the natural forest, which we call new deforestation, or they could maintain natural forest. That are the options, and the farmers can decide how they allocate their land. And they do this to decide how much of these different land use types, these 7 here, would the farmers like to have as a vision in future. So now the philosophy of our modeling is that we consider this satisfaction indicators, which is, for example, the net present value. So all discounted cash flows the farmers anticipate for the future are summed up, giving kind of a land value. So for two levels of time preferences, we considered the net present value. The labor demand, which is necessary for the different land use types, is another indicator, and payback periods. So how long the farmers have to wait to receive back the money is also important. And here we have the four indicators where the farmers, the mestizo farmers and the Saraguro farmers, have been asked for their land use preferences. You see that we standardized the performance of land use types between 0 and 100%, so that the indicators are then really comparable. They have all different units, and we must remove the units so that the indicators become comparable. So we standardize between 0 and 100%, and you see also a variation of what a specific landscape composition can achieve. That is because of the uncertainty. We always consider per land use type a pessimistic and an optimistic value, and all combinations between the 7 land use types, giving us 2 to the power of 7 combinations, and that gives here the variation. You see, in some indicators the performance is very low, it's only 0. And in some situations, the performance is 100%. That is not so well balanced and can be improved. Now our model reallocates land from this composition to this long-term composition. You see that is more diversified. There are afforestation areas here, also low input pastures, intense pastures, new deforestation, and remaining forest area, to enhance the performance of the indicators. And it is done so that the maximum difference between the best to be achieved and what is actually achieved is minimized. So that is the idea. In scientific terms, this is called satisficing decision making. It's not maximizing one thing. It is to be content in a lot of situations under uncertainty that an achievement of 40% in this case is always guaranteed. So that is the logic of the model. And now important, the preferences of the farmers have been directly asked for by a group of colleagues, Andres Chiericke, Maria Sandoval, Professor Pole, and they offered us to use the data. They are also co-authors of the study. And what we see, the main message is here that this intensified pasture is not really preferred by the farmers. They have ecological concerns, it costs a lot of money to have the fertilizer, and they fear a little bit that their lands are degraded by too intense pasture management. So that is a first sign that there could be a problem in the sustainable intensification. These indicator levels are also then specific for each land use type, are considered in the optimization. So the new study now has enhanced the existing model by the aspect of off-farm income, which is quite important. And this off-farm income means that we do not receive only the income of the farm, but we also have to reallocate on-farm labor to off-farm activities. So there is a twofold effect on deforestation. The farmers do not have anymore so much labor capacity for deforestation, and the income is more independent from deforestation. So that is considered, in addition to the basic model, we consider conservation payments. So we figure out how much money we must give the farmers so that they would refrain from deforestation. And we consider also how much money would we have to transfer to the farmers that the sustainable pasturing would expand. That are the agricultural subsidies. We then consider 3 scenarios and compare them. One scenario is that we just use compensation payments without caring for the food production. And this showed us that we produce then gaps. So we don't have so many food with the conservation strategy as with the deforestation strategy. That is the problem. So if we want to conserve the forest, on the same area we can't have agriculture. So we would need an alternative, which could be this intensification. The second strategy we called command-based sustainable intensification. Here we used constraints to force the area of intensified pasturing to expand in a way that the food gaps are closed, so to compensate the lacking food. And the last one is, that is then more voluntary. We spend some agricultural subsidies to incentivize the farmers to expand this intensified pasturing area. That are the three scenarios I will now compare. So first, let's look at the reference scenario without any intervention. So what would happen in the area with the land if we would leave the farmers decide based on the 9 satisfaction indicators to minimize their so-called dissatisfaction? So let me explain the graphs. You see here percentage values and you see colors. The green color is natural forest. This light color here, yellowish color, is pasture. The purple color is intensified pasture. The orange and this green color here are reforestations, and the gray color are abandoned areas. Up till this dotted line here, we have remote sensing data. That is the observed development of the land allocation in the investigation area. From 2015 onwards, our scenario starts, and we see here already a slight effect of this off-farm income. So the first scenario is without off-farm income, and we can compare the mechanistically projected area development of the natural forest. It deviates slightly from the statistical trend. When we include availability of off-farm income, we have a very good alignment of the statistical trend with the projected development of the agricultural area. So this makes our projections more realistic, and it shows that we can save a little bit of forest area only by enhancing the independence of the farmers from agricultural income. So these are the baseline scenarios. All the other scenarios are now compared with this scenario here. So now the conservation scenarios are, I introduced already 3 different kinds of scenarios. First is only issuing conservation payments without taking care about the food production. The second is, you see that here in the first scenario, without considering food production, this intense pasturing, purple area, is only of minor importance. But when we would like to close the gaps, the lacking food we have, then the area of the intense pasture needs to expand. You see this here, that is on the cost of the afforestation areas. We have a higher proportion of the intensified pasturing. And we see the same for the subsidized sustainable intensification. Here is the forced, and here is the subsidized sustainable intensification. So there's hardly any difference, only here maybe we have less pine areas. So what we can conclude that under sustainable intensification, the intensively managed area, the purple area here, needs to expand significantly. And why this expansion is needed is shown in the next graph. Here I compare over this timeline from 2015 to 2045 the relative development of the food energy production, and the reference is the red line here. So under deforestation scenario, we have an increase between 2015 and 2045 of 30% or even more, 145% in food production. If we now consider there's off-farm income available, we have less deforestation, we have less food. you see that only the presence of off-farm income reduces already by 25 percent points the level of food production. If we have total conservation of forest without any compensation of the food production, we have this really huge food gap here at the end, which is in the order of 70 or 75 percentage points. And that, I mean, cannot be socially acceptable, of course. We must somehow align the same food production as we would expect under deforestation with the forest conservation. And we have now tried to achieve this with an expansion of these intensive production areas, the intensive pasturing. And here's some information about the costs. What would it cost for the 3 different conservation strategies? We see when we would consider only the conservation payments, incentivizing the farmers not to deforest anymore, would cost around $80 per hectare and year. That is not so small amount, so it's really a lot of money. If we have the command-based sustainable intensification or the subsidized, we have only in the order of $50 per hectare and year necessary conservation payments. Why is that? Because when we have the intensified use, the farmers need to allocate a lot of labor in this activity. This labor is not anymore available for deforestation. Therefore, here it is relatively more cheap to have this conservation of the forest, while it is debatable whether the farmers would do this here. That is only command-based, and we assume they would expand this intensified areas, but probably they would not do. But for money, and here the money is really high, which we would need, we could have an incentive that the farmers would expand these intensified pasturing areas. But you see, compared to the conservation payments per hectare of recultivated area, we need a lot of money. It's $220 up to $400 per hectare and year. So that has to be kept in mind to convince the farmers economically to do this expansion. Is a lot of money is necessary, and money is not the own decision criterion. It is only the social preference which we have to consider. However, when we now have a more comprehensive view, what this would mean for an average hectare of a farm, we should consider the land use composition as well. So not the single options only, here natural forest and intense pasture, but the costs per hectare of average farm. So we see when we then compare this pure forest conservation, that per average hectare would cost us $40 because we have 50% of area under natural forest. Then for the pure forest area, it would be 80, but for this 50% would only be 40. So for the landscape perspective, it would per hectare be cheaper. And when we then compare the subsidized sustainable intensification, is not so expensive at the beginning. It is even a bit cheaper, but then in the long run, it could become a bit more expensive. But at the beginning, because the area of this intensified production is so small, then for the landscape consideration is not so expensive. So that could work, but if we consider all the indicators, then the picture changes a little bit. Let us first consider the strategy where we force the farmers by some regulations to expand the intensified areas. What would happen with this decision or satisfaction indicators? You see here, these are percentage points, and you have in mind the relative achievements between 0 and 100%. And these differences are percentage points, and you see that then especially this social indicator here, the preference of the farmers, the direct preference would decrease a lot. So we have here really big disadvantages, and naturally also the labor demand indicator, the light blue, would also decrease, because this intensive pasturing is so labor demanding. The other indicators are not so much affected. When we then have maybe the more attractive, from the perspective of the farmers, more attractive sustainable intensification scheme of subsidized intensification, we have for the economic indicator is much more attractive for the farmers. That is good news, but still we have here this not so good preference and not so good labor demand indicators. So to sum up, command-based sustainable intensification would worsen the farmer acceptability of these land use trajectories very severely, while with the subsidized sustainable intensification, at least the economic indicators improve, but the social indicators do not improve. So that might sound now a bit destructive and pessimistic, but I think we must also point out things which could cause problems, not having the solution already right now at hand. So my conclusions are that this land use model can help to show undesired or undesirable effects when implementing new strategies. We have seen that the social acceptability could be a major obstacle for implementing sustainable intensification. And the farmers, they have ecological concerns, and also they have scarcity of labor available at their farms, and that can make this intensification less attractive. So when a solution could perhaps be to at least resolve these ecological concerns, to have nice landscape mosaics, embedding the intensified areas into afforestation areas, maybe to keep the groundwater clean and reduce the environmental impacts. The acceptability is, I would say, rather a social science problem. It is not only the money, it is also the other concerns of the farmers we have to consider. And finally, at least we can see that the money could help to enhance the farmers' well-being and maybe in the long run also the acceptability of sustainable intensification, which is so far not to be expected. Yes, and that was my presentation. Maybe it was a bit dense, but I hope that I could have made clear the main issues and the main messages. I thank you very much for your attention.
Thank you, Professor, for this very nice presentation. Si alguien en la sala tiene alguna pregunta. Okay.
Santiago, I think there would be one.
Okay. Thank you.
Thank you very much, Professor, and congratulations for the conference. My question is related with the conclusions. It's not easy to establish good policies to economical policies related with the transfer money. You know? How can we start this kind of policies in our countries? Maybe you know some experience from other countries, maybe from other regions around the world, that you can talk a little about this experience to understand this experience in other countries.
So I think the problem is at least twofold. The first, we need money to have transfers to the farmers, that these strategies become acceptable, but we must also transfer knowledge. So how can we use the land in a sustainable way so that we can minimize the adverse consequences of this sustainable intensification? Because this means we need to use fertilizer, and we must somehow make sure that these fertilizers would not maybe pollute the groundwater and have adverse effects by maybe emissions of nitrogen and so on. And here I think innovative research about, for example, silvopasture or agroforestry systems could really help to have new innovative land use options, which we then must, of course, investigate quite properly, but then could transfer to the farmers to enhance the acceptability of maybe increasing food production, but not compromising the environmental issues. And for the financing, of course, one could also demonstrate the society how much more carbon, for example, is restored in the tropical forest when we reduce the deforestation. So on average, we could expect that maybe 100 tons or 100 megagram of carbon would be fixed in the living biomass of the tropical forest, which would correspond to about 470 or so, or 370 tons of CO2. If we would multiply this with a social cost, which could be 30 or so, then we would have quite a nice amount of money, which we could then use if we could attract this from some, maybe industrialized nations or so, to finance then the compensations for the farmers. There are only some ideas, but as I said, I do really not have the complete solutions. I can only point to a problem we have, but do not have the solution at the same time. We still have to investigate this.
Thank you so much. I have also another questions. I'm going to start with this. Professor, which conditions are recommended for upscaling the modeling to other ecosystems?
Yeah, I think the basic model structure could very well work also for other ecosystems, but what we would need is, of course, the socioeconomic and the capital budgeting data for the other regions. So we can't use the same coefficients which we have used here for the study area and then imply that this would also work in the dry forest or in other countries. In the research group, Jonathan, for example, is now about to work out new coefficients for the dry forest area. And then, in association with our colleagues, we will also use these scenarios to make especially explicit upscaling to larger areas. Even under the impact of climate change, a process-based model would deliver us coefficients, how the productivities and would change, and even maybe the suitability for corn or so that we could address also the impact of climate change. But that is only a promise. We have not achieved this, but in future we will work hard in collaboration with our Ecuadorian partners on these issues.
Nice, thank you. Also, another question. How efficient could be this kind of indicators or compensation, especially in Ecuador, when poverty is over 60% in rural areas?
So I would say, in this regard, if we have really these poor conditions, we should have really good preconditions for successful compensation programs. I know about the Socio-Bosque, and there are really good scientific evaluations which have proven that we really have additional deforestation reductions. And also for Africa and other countries, we have very promising research about only few money transfers, and they could really effectively reduce deforestation. So in this regard, I would be very optimistic, but it must of course be accompanied by good technology transfer and scientific consultancy, but then I'm optimistic that it could work.
Okay, thank you. Another one. How could social and economic indicators reconcile in sustainable intensification scenarios?
So I think we can, to reconcile food production and forest conservation, I could show it is possible, but it is a theoretical exercise. So if we consider the preferences and also constraints and the fears of the farmers, we still have a lot to do to convince the farmers that it could be an option. So I cannot say that this will be a really easy solution, but I don't have another idea how we can align this increasing food demand with conservation of this very valuable tropical forest. So somehow we must achieve a better production, more sustainable, and even higher quantities than we have achieved now, because the number of people is still on the increase. Until 2050, we will have 2 billion more, and they need food, of course.
Nice. Also, another one. How important is the state investment for this type of modulation, especially for compensation payments?
I think it's very important, but I think we can also involve the other nations. Because I mentioned these climate effects of the tropical forest. One can say the tropical forests are the lung of the planet. So they provide us with a very good climate regulation, and all the countries benefit from this. And therefore, I think we can also involve other countries to help financing this. There are many options. So we have another project where auctioning of conservation products have been tested, and that is also very promising, that there are maybe some big industries, they can bid to achieve then specific conservation of biodiversity, and there are many financing instruments which could work to help to get these financial funds necessary to stop the deforestation.
Nice. Also another question from social networks. First of all, thanks for the nice presentation. Knowing that the studied area has one of the most biodiversity forests in the south, how money compensation will reduce the pressure on forests and not becoming a vicious subside? The compensation program is just related to the money, or other forms of compensation can be used?
Yeah, what I offered here are just some rough ideas. What could be the monetary dimension? And I have shown that this is quite expensive. It is not so cheap. But I emphasized also that money alone would not solve the problem. We need to embed these policies in a very good consultancy of the farmers, so that we really can achieve this sustainable land use. But I'm very confident it is possible. What we have to avoid is this, you might have heard about the rebound effect. If we would just subsidize without any conservation payments the intensification, and then expect that then automatically the tropical forest land is spared, that could be a very poor decision, because if we make agriculture more profitable, then the incentive to expand agriculture would also be boosted, and then we could at the end have more deforestation than before. But when we combine it with conservation payments, which are conditional on really the preservation of the natural forest, I think we can fix this problem.
Okay, and I think that the final one, how to make governments take this type of research into account when formulating their policies?
So I must admit, I did not really completely understand. Maybe you can repeat.
Yeah, it's also for social network. How to make that governments take this type of research, your research, into account when they make the formulation of their economic policies?
I think that is also a task for science. So you have seen this is a bit complicated. Maybe I was also not able to explain everything so nicely, and that is our problem in science. Nobody understands us. So we need somehow, of course, the transfer. And I've seen very nice structures here at UTPL, how this communication between science and the industry and policy can be improved. I think if we would have a translator explaining the politicians what we mean, I think then altogether we could achieve something. But at first you need the evidence, and the evidence requires a little bit theoretical considerations, and then the research results must be prepared, so that I'm sure that the politicians would also accept and acknowledge this. Otherwise, we would not have the Socio-Bosque, for example. I think they are really encouraging examples that it could work.
Okay, thank you so much for really important presentation.
I think
also, thanks for attending this presentation. Okay, a final one.
Hi, Professor. Thank you very much for your presentation. It was very interesting. This is not my topic field on research, but I would like to know a bit more about the model you were explaining. So what are the main assumptions behind? Because at the end you said like money is still important. So sometimes models are built because of the assumption behind. So I would like to know a bit more about this economics assumption that you include in the model in order to understand why at the end money is important, but also this social adaptability has some issues, because we have in some way to combine people that conservative is important. So could you explain this, please?
I think you could classify this type of deforestation models into more maybe economic models where maybe as economic indicator is maximized. Often it is the sum of the discounted cash flows, but that would disregard a lot of aspects which are also important for the farmers. For example, with an afforestation, you could have a very good economic performance, but you must wait 20 years until you get the money. Not acceptable for the farmers. And therefore, our idea was that we would consider a lot of indicators, not only money. So it's a kind, we call it multiple objective optimization. And then we just assumed it could be a good idea to have 9 different satisfaction indicators, and each indicator, none of them has a priority. For the farmers also, that they have enough labor to carry out all the activities is important, maybe equally to the financial performance. And they were all considered simultaneously. And for all these indicators, we have a best value. It's the best a farmer can achieve. But he cannot or she cannot achieve all the indicators at the maximum at the same time. So then the task at the end was, what is the best compromise? And this is, I think, it's not so unrealistic. So when I was a pupil in school, then I had many weaknesses in many of the disciplines. And then I started, sometimes I did not start, but sometimes I started where I was weakest. And this was improved. And then the next is improved. And the same is mimicked by this optimization. And compared to the historical land use developments, it's quite nice. So we get really a good extension of what we have observed, and therefore we think it is a quite nice reference. And an alternative to the classical pure economic deforestation models, they would predict all the forest disappears immediately. And that is also unrealistic. I think we have here kind of a more realistic approach.
Thank you so much, profesor. Muchísimas gracias a todos quienes nos acompañaron en este evento, tanto en esta sala presencial como a través del portal web de la universidad y de redes sociales. Muchísimas gracias, una excelente tarde. Thank you, profesor.
Hemos dado mucho para poder llegar, pero ¿por qué simplemente llegar si podemos ir hacia adelante? Ir más allá de lo que conocías, buscar nuevos desafíos, vivir experiencias que te abrirán nuevos horizontes, empezar a brillar. Porque llegó el momento de volver a atreverse, de mostrar nuestra esencia, porque la superación es el premio cuando ya lo has intentado todo. Que ni el tiempo, ni las distancias nos arrebaten ese gran objetivo, porque nos dimos cuenta que romper esas barreras nos permitirán trascender. Y si pensamos diferente, disfrutando cada momento en que despertemos ese potencial, donde la investigación, el trabajo y la innovación nos permitan poder transformar el mundo, dejemos que este renovado entorno de aprendizaje nos inspire y exterioricemos todo eso que nos hace únicos. Y ahí está nuestra misión, ayudarte a encontrar la mejor versión de ti mismo. Nos une ese anhelo de juntos construir una universidad de calidad, inclusiva e innovadora, porque no olvidemos que todo es mejor cuando lo hacemos en equipo. Cumplimos 51 años de brindar una educación superior de calidad, con docentes, investigadores y soñadores que están decididos a siempre ser más. En AUTPL nos apasiona servir y brindarte un ecosistema educativo de excelencia, sin fronteras, porque con convicción, humanismo y perseverancia podemos ir hacia adelante. Universidad Técnica Particular de Loja decide ser más.